Hello everyone, this is Sooraj Kumar. I'm a graduate student at the School of Building Construction at Georgia Institute of Technology, and today we'll be talking about exploring the synergy between lean construction and flash track implementation. We'll take a look into the problem statement, the introduction to flash tracking and lean construction, the methodology, results, and the conclusion. The U.S. Bureau of Labor Statistics indicates that the construction productivity has declined by 0.5% each year from 1964 to 2003. Reason for this poor performance has been attributed to industry fragmentation, excessive litigation, diminished skilled workforce, limited collaboration, and a lack of trust. With an increasing demand for faster project delivery by owners for reasons such as emergency rebuilds and competitive market forces, challenges of planning and coordination of construction work need to be addressed for their timely completion. Emerging trends such as BIM, lean construction, IPD have been used in recent construction projects to address the issues of fragmentation, delays, waste, and inefficiencies through improved project integration. Numerous case studies have been undertaken, which show that the implementation of lean principles have led to an increase in productivity, minimized project duration, expanded efficiency, and enhanced the profitability. Due to these proven results, this review paper aims to investigate the use of various lean tools and principles in flash track projects and find if and how there is synergy between lean and flash track implementation. Flash tracking has been defined as time-driven projects which by necessity requires a heightened degree of concurrency between engineering, procurement, and construction, and differs from fast tracking on the basis of time. Thus, it denotes faster fast tracking, which requires intensified planning and coordination. The risk associated with flash tracking includes volatility risk, in addition to typical risk of cost overruns, design errors, change orders, and rework. However, this paper conjecture is that these flash track risks can be mitigated through lean construction with the help of careful planning. Construction Industry Institute has defined lean construction as the continuous process of eliminating waste, meeting or exceeding all owner requirements, focusing on the entire value stream, and pursuing perfection in the execution of a construction project. Lean is a way to design production systems to minimize waste of material, time, and effort in order to generate the maximum possible amount of value. The idea of the new production philosophy first originated in Japan in the 1950s through the Toyota production system for eliminating inventories and other waste. The term was first used in 1988 and applied to construction in 1993. 8 lean principles have been analyzed for their application in flash track projects. These selected principles are reducing variability, which can be in the form of workstation setup and production rates, reducing batch size, which is the total number of locations that are assigned to a trade crew to work in at any given point of time, using multi-skill teams, which can be used to improve the work process, where each team performs larger packages of continuous work, instituting continuous flow, type of production line through which work is advanced from one production station to another on a first-in, first-out basis, pull system, where work commences only by a demand from downstream workstation in a pull system, and instituting continuous improvement. The concept of continuous improvement was developed by Toyota Motor Company in 2001, and it can be developed through daily Kaizen, where the workforce is not only challenged to do their work, but also be responsible for improving them. Lean principles serve as foundation on which lean tools have been developed and used in the lean project delivery system. It is intended to improve the delivery system by minimizing waste, improving flow and productivity in a construction site, by guiding people to think in a lean way. This paper considers 11 lean tools. Last planner system, which has been successfully implemented to stabilize workflow by making plans predictable and reliable. Concurrent engineering, which is the systematic approach to the integrated design, construction, maintenance, and operations. Just in time, which is a technique developed by Taichi Ono to reduce inventory and is employed to increase efficiency and decrease waste by receiving materials or equipment. 5S stands for sort, straighten, shine, standardize, and sustain, and is a process of waste removal from the workplace with the use of visual controls, thus keeping the work environment organized. Daily huddle meeting. It is a technique which involves crew workers in the planning of everyday tasks. A3, which is a tool used to assist the user to execute the plan, do, check, act process. Kanban, which is a Japanese term meaning cart or sign and is a lean approach to pull materials and parts throughout the value stream on a just-in-time basis. Pokayo, it is a Japanese word which means mistake proofing. It uses visual or other signals to detect and prevent errors in processes with the aim of achieving zero defects. Work structuring is a fundamental form of planning which determines what work must be done and who would be best suited to execute it. Work standardization is the extensive use of successful practices or procedures in a regular, repetitive manner. Value stream mapping is a technique for visually analyzing, documenting, and improving the flow of a process in a way that highlights improvement opportunities. The primary purpose of this research paper is to examine the potential synergy between lean construction and flash tracking by exploring the rationale and gathering practical evidence from the existing publications. The research methodology involved three phases. Phase 1 focused on the literature review on lean construction as well as flash tracking. Phase 2 entailed the data collection on various lean tools and principles implemented in construction projects. Phase 3 entailed the data analysis of the relevant lean tools and principles in flash tracking. This was implemented in two steps. Formation of the rationale that presents the logical synergy between each lean tool and principle, and the identification of evidence from the publications. Results show that there is a high synergy with using lean principles and flash track projects, with 6 out of the 7 lean principles having a positive synergy with flash tracking. Reduced inventory has a negative synergy, as flash tracking calls for increased capacity of buffer stock. Similarly, there is a high synergy with using lean tools and flash track projects, with 9 out of the 11 lean tools having a positive synergy with flash tracking, whereas just-in-time was shown to have a negative synergy due to the reduced inventory. This research demonstrates rationally the synergy between lean and flash tracking and documents the practical evidence. However, future research could further validate these interactions. In the end, it is important to understand the value for the client first and justify lean practices only if needed in a flash track project. Thank you.